Here is an explanation for the answer to final exam question number 38 in Electronics Demystified, 2nd edition. If you have the printed book, please refer to page 425. This is the same figure 7-4 that we saw in the explanation for the previous question number 37, which asked us about various types of amplifier classes. Well, this is another question having to do with various types of amplifier classes. This particular graph shows the bipolar transistor characteristic curve of collector current versus base current. Now we're talking about what we want if we intend to use this as an amplifier for a single sideband radio frequency signal. Here's what the characteristic curve looks like. With reverse bias, under no signal conditions, we get no collector current. Once we reach a very small forward bias, equivalent to the forward breakover voltage of the emitter base junction in the bipolar transistor, we begin to get current. And then we reach a point where we have the straight line portion of the curve. By straight line portion of the curve, we do not refer to this part of the curve, but we refer to this part of the curve. That's Class A operation. Class AB operation, the signal makes an excursion into the nonlinear part of the curve like this, and there's class AB1 and AB2, which are discussed in chapter 7. Class C operation, under no signal conditions, we apply enough reverse bias to cut the device off, so that in order to get current we need to provide a lot of driving power, significant amount of driving power, so that we get current to flow at least during part of the cycle. Well, which one of these classes of operation, class A, AB1, AB2, class B, at which we bias it at exactly the cutoff point under no signal conditions, or class C, which one of these would we not want to use for a single sideband amplifier? For example, the power amplifier in the output of a radio transmitter. And the answer is class C. We do not want to use that class of operation for single sideband because it will introduce nonlinearity into the waveform or the modulation envelope of the signal. Now there's a difference between linearity and a radio frequency power amplifier, which can occur. We can get that with class B, we can get it with either class AB1 or AB2, and we can get it with class A. We can't get linearity in a radio frequency power amplifier with class C operation. In an audio amplifier, in which we were dealing with the previous question number 37, we were talking about linearity for the actual input waveform. That requires that we go only within that straight line part of the curve. But if we want to use a radio frequency amplifier, the modulation envelope is a different animal from the signal waveform itself. These classes of operation, AB, okay, try that again, AB, B, and C, will introduce nonlinearity into the signal wave itself, but that does not necessarily disturb the modulation envelope. So we can get away with class A, class AB, AB1, AB2, or class B operation in a single sideband amplifier. But class C, nope, we can't get away with that. So the correct choice to this question is choice E. Class C operation is a no-no with a single sideband transmitter.